Welcome to my YouTube channel Raise a Cat, and today in the chemical bonding section we will be seeing with some of the bond characteristics which are involved in the chemical bonding or in between the atoms in a particular compound. Okay, so bond characteristics, what are the different types of bond characteristics that are involved in this chemical bonding topic. Okay, so we will see what are the bond characteristics. So first bond characteristics is bond energy. This is very important thing, bond energy. Second is bond length, and third one is bond angle. Okay, so bond energy, bond length and bond angle are the three characteristics of a particular compound. Okay, so this we will see what is this bond energy, bond length and bond angle in a particular compound. Okay, so firstly starting with this bond energy. So what is bond energy? Okay, so bond energy is nothing but, for example, there is a particular compound, this CH3. So for example there is this okay, this CH3 and here H and here H and here also this is this CH3. Okay, and this is double bond. Okay, so for example this is the compound. Okay, so there are different types of bond involved in this. This is double bond and these are all the single bonds which are there in this. Okay, so what is there? So in this in this hybridization is sp3. Okay, so hybridization is as sp3. So these are more stronger than these sp2 bonds. Okay, so to dismantle this compound or to break this bond, this bond between CH3, these atoms will be more difficult than to break this pi bond. To break this bond between the single bond C will be more difficult than to break C double bond C. More easy. This is more easy to break C double bond C, and to break this C single bond C is more difficult, and to break this C triple bond C is further more easy. Okay, so what will be there in bond energy? Okay, so if we will be requiring less energy to break this C double bond C, so its bond energy is less. Okay, and we are requiring more energy to break C single bond C, so its bond energy is more. So like this bond energy is defined. Bond energy is defined as to break a particular bond between two particular elements, what energy we are requiring. So that is the bond energy of that molecule or the compound. And how we will find the bond energy of a particular compound? Will be the sum of all the bond energies between all the elements which are there. So suppose that there are 10 bonds, so bond energy, total bond energy of that particular compound will be the sum of all the bond energy between the particular elements which are there. Okay, so and C triple, to break this triple bond is bond energy is very less. Okay, so like this we define the bond energy. Okay, so there are some more cases. For example, this is this F molecule, hydrogen fluoride, HF, HCl and HBr, and this is HI. So as we know that HI has a more size, okay, this is further less size, and this is further less size, and this is fluorine has the smallest size in this halide atoms. So fluorine, chlorine, bromine, iodine, these are the 4 atoms. So this has a large size, this iodine atom has a large size. So and H atom has a same size in this all, H atom, H atom, H atom and this H atom. Okay, so this has a constant size H, and these size are increasing, and here if we say in this left direction the size will be in the decreasing manner. So what will be there in two, these are having a small size, so they are more tightly packed or bounded between each other. Okay, so they are less tightly bounded, okay. So what will be there, to break this bond will be very easy, because these are less tightly bounded and this is more tightly bounded. So to break this HF bond will be very difficult. So bond energy will be like this. Okay, HCl, HBr, HF, HCl, HBr, HI, because these are more tightly bounded and these are less tightly bounded, and because it has a more size and between H atom in comparison to H atom, so to make a good bond is very difficult to, and in this to make a good bond between H and F is easy, because the size are comparatively equal, or in the F has a smaller size. Okay, so to make this HF bond is very easy, and to break this HF bond is very difficult. So so this has so much of bond energy. So bond energy direction. Okay, so this is the bond energy direction in the HF, HCl, HBr and HI because they are less tightly bounded and more tightly bounded. So this is the direction. Okay, so next characteristic was bond length. Okay, so next characteristic was bond length. Bond length. Okay, so how we will describe, so suppose that there is one hybridization which is sp3, this is sp2 and this is sp. So bond length has largest of this sp3 and the sp has the smallest bond length. Okay, so this is the for the hybridization bond length which is there, that sp3 has the highest bond length and sp has the smallest bond length. Okay, so for example there is one compound which is like we saw, there are halide atoms, like halide atoms which are fluorine, chlorine, bromine and iodine. So for example these are 4 halide atoms, and if they have formed this HCl, HBr, this I. Okay, so this has the largest size and this has the smallest size. So this has the largest size, so the bond length will be more. more bond length. Okay, and this is the smallest size, so having a less bond length. Okay, so the bond length will be largest of this one. This will be having a second number, this will be in the third number, and this will be in the fourth number. So in the hybridization, this sp3, sp2 and sp bond length number is like this, first, second and third. And in case of halide atoms, it is based on the size of the particular halide atoms, and in this because it is dependent on the orbitals overlapping, orbitals overlapping. Okay, so or this we can say that this is a sigma bond has the largest bond length, then this pi bond, and this has the 2 pi bonds. Okay, so like this we can also reduce the bond length of a particular compound which is there. So for example, it has a triple bond, so it is having a less bond length, and if it is having a single bond, so it is having a more bond length. And if in the particular compound a particular element has more size, then it will be having a more bond length and less bond energy. And if it is having a less bond length, then it will be having a more bond energy. Okay, so less bond length, more bond energy. Okay, so this is for the bond length and bond energy. Okay, so if it is having a less bond length, then more bond energy will be there. Okay, and one more thing is there, that because of this, if the bond length is also dependent on lone pairs or repulsion effect. So because of this lone pairs, what is there? There is some repulsion effect which is there. So if it particular compound is having a, suppose that 2 lone pairs, and this is for example one element E1, and this is second element E2. Okay, and this is the bond, and this is having one lone pair, and this is having another lone pair. So what will be there? There is repulsion which is there between these atoms. So what will be there? There will be increase in the bond length. Bond length increase will be there, or the bond energy decrease will be there, because there is repulsion. So to break the bonds will be very easy. So E1 is having one lone pair, E2 is having one lone pair. So there is very repulsion in this. And suppose that there is one element E1 and this is E2, and these are not having any lone pairs, and this is bond. So this bond will be having less bond length, and this bond will be having more bond length, and this will be having more bond energy, this will be having a less bond energy involved. Okay, so lone pair or repulsion effect also will be there. Okay, and we saw this size effect also. If E1 and E2 having more size, then more bond length. E1, E2 having less size, then less bond length. And opposite is for the bond energy. Okay, so repulsion effect also happens because of this lone pair, especially because of lone pairs, this repulsion happens in the bonds. And we saw for the size also, that size, because of size also repulsion happens, and it affects the bond length and bond energy. Next is the bond angle. Bond angle. So how the bond angle is defined? Bond angle is defined as the bond angle is defined by angle between two elements in particular compound. Okay, so this is the angle between two elements in a particular compound. Okay, so for example, there is this CH4 molecule, and this is NH3 molecule, and this is H2O molecule. Okay, so as we know that this is a tetrahedral geometry and it is having a 109 degree angle, and it is having a 107 degree angle, and this water is having 105 degree of angle. Why? Because of this lone pair. This has lone pair 0. This has one lone pair and has 5 valency, 5 of N and 6 of O. So 1, 2, 3 and 2 electron in this lone pair. So 5 completed. In this 2 this and 2 lone pairs. So because of this the bond angle has decreased because of this lone pair effect. It is called lone pair effect. Okay, and the bond angle has decreased. But if suppose that there is having a bond angle between lone pair between this and this, so what will happen? The bond length will increase. There will be increase in bond length between if it has a two lone pair between this and this, because repulsion will happen, and it has if a particular element in this only the lone pair are increasing, so the bond angle is decreasing as we see in this case. Okay, the methane gas, nitrogen, ammonia gas, and this is water, H2O water. Okay, so this is the bond angle in this case. So this is very important to know this concept. Okay, so next we see because of repulsion, bond angle increases. Okay, so because of this repulsion, bond angle increases. Okay, so suppose that there are two molecules having large size, both are having large size, so bond angle will increase because this is element E1 and this is element E2. Both are having large size, and this is also large size. So to make a bond, this bond angle should increase only, because if it is having a less bond angle, suppose that this is a less bond angle, then it is E1 and it is E2. So to fit these elements in this particular compound will be very difficult. So bond angle increases so that there is enough space to fit these two elements E1 and E2. So if these two elements are having this is, suppose that this is A2, this is A1, so A2 will be greater than A1 because E1 E2 are greater than E1 dash E2 dash. Okay, so to fit these elements in a particular compound is now easy because angle has increased. Okay, so now a term is in the bond angle is also defined as conformation. Okay, so there are various type of conformation, like it is a boat type of conformation or a boat kind of shape and a chair kind of shape. Okay, and twisted boat kind of shape and twisted chair kind of shape. So like this, there are various types of conformations which are there depending on the bond angle. So suppose that this is a shape of this boat and these are the elements which are there. These are all the elements of a particular compound. Okay, so like this only the boat, chair and various types of conformation are defined, so that these bond angles should be perfect. Okay, so if a particular molecule is large, in that the conformations are defined, and in that conformations the bond angles, the particular compound tries that its bond angle should be perfect, so that it is very stable. So if bond angle is bond angle is good, then molecule is stable. Okay, so if particular molecule bond angle is good, then the molecule is stable. So this molecules or the compounds tries to fit in these type of conformations so that it is stable. Okay, so what happens, in the boat form is very stable among these all conformations. So the particular compound tries to fit in this boat